Cześć, witam Was na kolejnej prelekcji. Chciałbym tylko przypomnieć, że równolegle w trakcie Warszawskich Dni Informatyki odbywa się również giełda pracy IT, podczas której możecie aplikować do różnych ciekawych firm, zapoznać się z ich ofertami pracy. Warto, ponieważ część tych ofert jest tylko i wyłącznie na potrzeby jakby dzisiejszej i jutrzejszej konferencji, także są tam również oferty, których nie znajdziecie jeszcze online, a jednocześnie warto również skorzystać z konkursów, które są organizowane, ponieważ możecie wygrać Xboxa, Google Home Hub lub Xiaomi Mi Band, także warto. A naszym kolejnym prelegentem będzie osoba, która wystąpi w języku angielskim, także I will switch to English to announce our next speaker. The next talk will be given by Błażej Sewera, software engineer at Webfleet, one of the sponsors of our conference. In this talk, Błażej will talk about when it's good idea to use design patterns and why you should refactor them to improve the architecture of your solutions. Hello, Błażej, the stage is yours.
Thank you. All right, so welcome everyone to my presentation. I will try to present a little bit different approach to design patterns, which is in fact refactoring to them. So I'm Błażej Sewera, and as it was being said already, I'm a software engineer at Webfleet. All right, so maybe let's start a little bit philosophical. So what is a design pattern? Because design patterns are like a little bit broader term than only in software engineering. Design patterns are actually come from the architecture, like the building ones, from Christopher Alexander. So Wikipedia says that a design pattern is a reusable form of a solution to a design problem. And I want to stress this word problem because I think it's a very important and profound one. So we need a problem, right? So maybe a better question. So what is a software design pattern? The ones that we usually have to deal with. So a software design pattern is a solution to a software design problem. Nothing has changed, only software added. Actually, we still have to have a problem. So what do we get if we don't have a problem? We might get lucky and guess correctly that we are solving the right problem, but it's by no way guaranteed. So I propose that we don't guess, because from my experience here, I saw that it often makes people's lives harder. People do this to themselves, and it is done in small steps usually. So we guess here with adding a builder to a very simple class, that this class will change, as in it will have more properties in the future. But what actually may happen is that the class doesn't change the number of properties, but instead it changes a name. So we could have, for example, 1,000 colors, and we will need to update every one of them. So sometimes we want to simplify our lives and simply just use a normal constructor that can get whatever parameter we want. We don't have to think about names. It's only a simple idea, but I think it's very profound that with small steps we can make other very big positive changes or very big negative changes. So it's kind of fractal in that sense. Another thing I wanted to show you or to talk about is to always try to find ways to simplify your life. And what I mean by that. So Java is a little bit boilerplate code, but fortunately, with Java 17, we can use records. So all this messy code that you see here boils down basically to one line, which is very elegant in my opinion. Also, we live in the modern ages where we have such libraries like Lombok. So all this code boils down to a couple of annotations. So I think it's also very nice. So always try to find ways to simplify your life. All right, so maybe the last example of some kind of an anti-pattern is the project called FizzBuzz Enterprise Edition. Some of you might have already seen it. I think it's a work of art. So FizzBuzz is a quick introduction. FizzBuzz is a game for children to teach them how to divide by different numbers. So when you have a number that is divisible by 3, you say fizz, and that is divisible by 5, you say buzz, and the number that is divisible by 3 and 5, you say fizzbuzz. So 1, 2, fizz, 4, buzz, and so on. Very simple idea. So you probably have in your mind a way to implement it in code very simply, but what FizzBuzz Enterprise Edition made, again, it's a work of art. I highly recommend you Google it. So what they implemented is they implemented almost every design pattern that is available from the book, by the Gang of Four, and they came up with such a masterpiece that is unnecessarily complex. It's totally unnecessary. It works, sure, but it is so overly complex that it is ridiculous. So for reference, this code here, this very big block of code, boils down to that the integer is not divisible by 15. So all of it is like boiled down to one acronym, YAGNI. So it's you ain't gonna need it. It's like a concept from the Extreme Programming Explained book by Kent Beck. So he proposes that you simply relax, don't try to guess what the hardships of the future will be, and simply try to make a simplest, not to confuse with simplistic, the simplest working solution that works for the problems today. So are they mutually exclusive? So is the YAGNI idea and design patterns mutually exclusive? I think not. And what glues them together is a concept of refactoring. Many people are already familiar with refactoring. You do it every day. Simple renaming is a refactoring still. But today I want to show you a little bit more complex idea of refactoring. So refactoring to patterns, and I will do it on an example of a product export, kata. Kata is a quick like exercise to brush up on your programming skills. This one is called product export, and a quick introduction for it. So you've got a bunch of products. You can put or stock those products in a store, or buy a product and it goes to an order. Then you collect all the orders and you export XML, or you export XML from the stock of your store. So it's a simple program, has a bunch of classes in our domain, and it simply produces an XML which is similar to this one. So what's the problem in this kata? So this kata is meant to be overly complicated. It's like everything is connected with everything, so it's a dependency mess. As you can see, the architecture is very brittle because the main class, the XML exporter, it is dependent on almost every class in this domain. So it's very brittle. If any class changes its structure, the XML exporter and a bunch of other classes have to update as well. So what does it look in code? This is very brutal, I know, but I don't want you to read all of it. I will go through it. So first of all, as you can see, the XML exporter needs to know about the structure of order. So what fields or what accessors in this context it needs to have. Then it needs to know that the order has a bunch of products in it. Then we get even deeper, and the XML exporter has to know the structure of a product itself. And last and the deepest one is that the XML exporter needs to know that the product has a price and the price has a certain structure. So we don't want it, obviously. We want to only be dependent on the things that are immediately important to the XML exporter. So for that matter, we only are dependent on two things here. As you can see, there is an account, a new concept that I will talk about a little bit later. But generally, it's far easier to reason about, and it's like miles better. So what does it look in code? Very simple, one line, one return. It's like a breeze to work with right now. So a little bit on the account, because as you saw, this refactoring uncovered some new concept. So we can just take from the domain-driven design a bit, and we bring our domain expert. And when we actually refactor to the design patterns, we might uncover some new ideas. So we then bring our domain expert and ask them, hey, how do you call a list of orders? And like he says, I don't know, off the top of my head, I don't know, ledger. But you know, after a bit of discussion, he says that all right, a better name will be account, and that is also a like very profound side effect, so to say, of refactoring, that you uncover new ideas, because when you extract some idea, and you distill it, you simply sometimes have to name it. So you may want to bring in a domain expert and align the business vocabulary with the vocabulary in your code base. So we got this whole mess in our code, and we wanted to simplify it. So the design pattern that you may already thought of, that that solves it very elegantly is a composite. But I don't want to talk about, we got a bad design and we simply change it to a composite. I want to talk about the road to the composite. So the refactoring is called in the Refactoring to Patterns book, replace implicit tree with composite, because as you may have seen, this piece of code or two pieces of code is actually an implicit tree, because we implicitly specify in our code that we have some structure, but it's written in a all in the same place. So composite actually, when we extract it, and I encourage you to do it in very small steps. When we extract it, we find that it simplifies a lot our design, but when we extract the component from the composite, we find out another very profound feature of this refactoring, and this is that we improve the cohesiveness of our design. So we only access the variables that are immediately in our object or in this example record. And as you may have seen already, it's like almost copied and pasted code. It's on purpose and by design, because we only want to take one small step at a time, simply run all our tests, and they should pass. And then we commit, obviously, and move on with our refactoring. The point here is that even if we don't have any more time for further refactoring, we always leave the code base in a better state than previously, and also in a working state. So our code base is always working, always releasable. So then we can enable, for example, continuous delivery straight into production after each commit. So also, you may have seen that after those refactorings to a composite, we still have a very procedural code. So it specifies in detail how do we construct an XML tag. So we have obviously a tag with a name, which is constructed in three different places in code. We have a parameter, which is also constructed with 3 lines of code. And we have some value, which is somewhere in the middle. It's not like we reason about this code line by line, but we reason about it jumping through the code. It's a problem with procedural code, that we specify how do we want to do things, but not what do we want to achieve. So a more declarative approach is to specify what do we want to achieve without specifying how do we want to do it, and just delegate how do we want to do it somewhere else. So here the construction of XML tag reads like line by line very naturally. So we want a tag, obviously, with a name. In this case, price, with a parameter of name currency, and with value string of our variable currency, and with tag value, which is the amount that we want to put in our XML tag. So as you see, and the name XML tag.builder suggests, this is solved by a design pattern called builder. You may have already thought about it, but as previously, I want to tell more about the road to builder. So the refactoring is called in the book encapsulate composite with builder, and we simply want to delegate the procedure and extract and distill only the declaration, what do we want to achieve, not how do we want to achieve it. So as you can see, it's like a very simple XML tag builder. We have what do we have in an XML tag? So we have a name, we have some value, we have some parameters, and we have some nested tags that are children. And all the boring stuff is simply put in this one method, which is toString, and it produces an XML tag, a string representation of it. But as I said previously, we want to do it in small steps. So first, what you want to think about when refactoring is that you want to delay the breaking of the interface as much as possible. So unless you know that you don't have anything more to do, don't break the interface. So as you can see, we have a declarative part of it. So we specify which tag do we want to have in our method, and then a little bit of procedural code. We simply append it to our final XML. Again, all the tests pass. It's a very simple step. The commit for it has only a bunch of lines added and deleted, so it's also very easy to reason about. When we are done with every class in our system that we wanted to refactor in that way, we can simplify the interface and just migrate it to only to the declarative approach. So as you saw, there were many small steps, but there is a big change. So all the steps in this exercise took 114 commits. 40 files were changed. Only for tests and configuration, over 500 lines of code were added. And for the production code, over 500 lines of code were added, and almost 500 were removed. And the full refactor, so the PR that you would get if you made a PR from it, would take almost 1,500 lines of code to read, so both added and deleted. But an average commit was very small. It was under 20 lines of code added and deleted, so it was very easy to reason about. So another idea that I would propose from the Extreme Programming Explained book is pair programming. I think it's a very good tool to have when trying to make big changes in small, safe steps, and you have an ongoing, continuous code review. There were, however, some of the things that are out of scope. Unfortunately, I didn't have time today to to present some of the characterization tests that are mentioned in the Working Effectively with Legacy Code book by Michael Feathers. Very great concept, especially for refactoring some legacy code. Also, another cool concept that you may not have heard about yet is TCR, test and commit or revert. Kent Beck has very great materials on it that I will give access to you later, or give links. Also, yeah, I know money as double. You don't want to do that. It's very unexpected things may happen, but it's out of scope of this presentation. And Java util date is also a very bad idea. There are far better alternatives, but it's also out of scope of this presentation. Another thing is further refactoring, so extracting XML representation from domain objects, because right now the domain objects have an XML method, but yeah, that's the whole point of it. You just simply make refactoring step by step and gradually go from worse design to better design. And the usage of proper XML library will also be great, but I only wanted to show you the gist of it, so I implemented some somewhat naive but very simple implementation. So to summarize, remember that you ain't gonna need it. We all hopefully write our code in an agile way, so the simplest solution is usually the best. When you're gonna need it, I will get to it, that you should refactor. Think about design patterns more as refactoring targets than like stationary big design upfront structures. They are very great ideas. They solve a lot of problems, but they are the refactoring targets. And it's, in my opinion, it's the most effective use of design patterns. Remember that a design pattern is a solution to a problem. So if you don't have a problem, don't solve it. As simple as that. You ain't gonna need it. Relax, take a sip of some tea or coffee, and yeah, just solve the problems whenever they appear, not before. Refactor if you need it. So if you have a problem, refactor to a better solution. That's usually the best approach. And remember that refactoring have to be in small steps. That way you have all your tests running, and you don't spend time on debugging. You spend more time on trying to understand your domain better, maybe distilling some new ideas. And all of that is possible when you make it in small steps. And of course, practice. And practice a lot. I highly recommend doing some refactoring katas. They're a great exercise. Emily Bach has a lot of the katas templates in her on her GitHub account, and you will see all of it under this link. So it's severa.dev/RTP. It's like refactoring to patterns. That's severa.dev/RTP. But if you don't want to go to this link, which has all the resources that I used in this presentation, you can also check out those amazing books, especially the first one, Refactor into Patterns, which is obviously the main book that I based my presentation on. So thank you very much for listening, and yeah, check out the link.
Thank you very much, Błażej. I see one question. Money is big decimal, but what about date replacement? Just the name of it, please.
Yeah, date replacement. Sorry, could you repeat the question?
I don't know this technical things, but the question is directly, money is big decimal, so it's a type probably, yeah. But what about date replacement? This is, it was written together, date replacement without space between, so probably it's also some kind of, I don't know, method or type, I don't know.
Okay, if it was connected with the Java util date, yeah, I know it's a bad class to use right now. If it's not, unfortunately, I have no idea.
Okay, maybe next question will be easier. What should we replace date in Java with?
Yeah, like local date, any like type that has localization info in it. The Java util date has another strange property that it exposes all the setters, and it's like a very procedural in nature. I would advise you to use as much immutable data structures as you can. Yeah, but anything that has localizations, so for example, time zone info in it is far better, and you will not have any, unpleasant surprises with it.
Okay, thank you for these answers. I see no other questions on the chat. So thank you, Błażej, for this interesting and valuable presentation. For our attendees, please rate Błażej's speech. You can do it under the video. And remember that you can apply for a job at Web3. For this purpose, check out the company's virtual stand on our IT job fair. Expo is available in your user account. So I think it's quite a good option. See you on the next session, and thank you.